Hi Leo students, Mr. Kaczynski with you. Practice your skills here. We're going to do the solutions for section 6.1 of our book. We got geometric recursive sequences here. All right, or multiplicative recursion as the book calls it. Give the starting value and constant multiplier for each sequence, then find the seventh term of the sequence. I think I'll type this in here. All right, so the starting value is obviously 16. And constant multiplier, I won't write this out every time, but let's see. What is being multiplied? Well, we could check it like this. Let's go 20. That's the second term in the sequence, divided by 16. That's the first term in the sequence, and that's 1.25. So in other words, 16 times 1.25 is 20, and 20 times 1.25 is 25, and then there's the 31.25. So 1.25, or we could write it as a fraction, 5/4, either one of those. That's our constant multiplier. All right, this one, we got 27 for the starting value, and the constant multiplier, let's take 18 divided by 27, and that's 0.6 repeating, also known as 2/3. So 2/3 is the constant multiplier. This one's kind of obvious, isn't it? I don't think we need the calculator. 1's the starting number, and then it's doubling every time. So you're multiplying 1 by 2 to get 2, 2 times 2 to get 4, 4 times 2 to get 8. So starting value is 1, the constant multiplier is 2. Let's see, 1 again is our starting value, and then I think 1/10 is our constant multiplier. Let's check that one just to make sure. Let's go 1, enter, times 1/10. There's our 0.1, there's our 0.01, there's our 0.001. So we're good there. 4.2 for our starting value here. That one's kind of tough to identify, so I'm definitely going to use the calculator here. Negative 14.7 divided by 4.2. And it doesn't matter which two terms you use. You could use 51.45 divided by the term in front of it, or the value in front of it, negative 14.7. And you still get the negative 3.5. That is our constant multiplier, negative 3.5. And one more here. Oh, they didn't give me the starting value. So what I'll do is figure out the constant multiplier first. So I'll do 729 divided by 2187. That means my constant multiplier is 0.3 repeating, or 1/3. So if I work backwards, what's the opposite of multiplying by 1/3? It would be to multiply by 3. So 81 times 3 is 243, times 3 is 729, times 3 is 2187. If I multiply by 3 here again, I'll get my starting number, which is 6561. So 6561 is our starting value there, because we multiplied by 3, kind of going backwards. So our starting value is 6561, and our multiplier, 1/3. 1/3 of 6561 is 2187. Next up, we're going to write a recursive rule to find the first 6 terms of this sequence. Well, the recursive rule is going to be our starting number, followed by hitting the enter button. And then we're going to take our answer and multiply that by negative 1.6 and hit enter multiple times. Won't overdo it, but there we go. So that's our recursive rule. Now let's actually use it. We know the first number is 100. Now we just need some more numbers. So 100, enter, times negative 1.6. There's our second term, third term, fourth term. And there's our fifth term and our sixth term. Ooh, ugly. All right, so there's all our terms. All right, recursive rule here for this one. We're going to start with 620, hit enter, and then we'll take our answer and we're going to multiply that by 1/2 repeatedly. So we'll hit enter, enter, and then hit it as many times as we need to. So obviously 620 is going to be our first number. Multiplied by 1/2 is 310, multiplied by 1/2 is 155. I better use a calculator at this point because I'll probably mess it up. So there's our starting number times 1/2, 310, 155, 77.5, 38.75. And I think that gives us everything we need. 77.5, 38.75, and 19.375. Those are the first 6 terms in our sequence. So notice that the first term is actually the starting number, okay? It's not term 0. We'll call that term number 1. Write each percentage as a ratio comparing the result to the original quantity. For example, a 3% increase is 103 over 100. Then write it as a constant multiplier. For example, 1 plus 0.03. Okay. So we'll write this as a fraction. It's, if we have an 8% increase and you started with 100, you're going to end up at 108%. Do we want to simplify this? That's the question. I think we'll just leave it as is. What do you say? Yeah, we'll leave it. All right, and then we're also going to multiply it write it as a multiplier. So that's like 1 as in 100% plus 0.08 as in plus 8%. Sorry about my tiny little 0 there. All right, so 11% decrease, we'd actually do 100 minus 11, which would be 89 over 100, which is equal to, again, 1 minus 100% minus 11%. So we'd write it like that. 12.5% growth. So I guess we're going to write this as 100 plus 12.5. I don't like this where we have decimals in our fractions. 112.5 over 100. I mean, they're not simplified anyway, but I think I'll multiply the top by 10 and the bottom by 10 and write it like that so I can get the decimal out of the fraction at the very least. Yes, we could simplify it, but so I'm going to go with that as my answer. And then written as a multiplier, we'll do 100% and then 12.5% growth would be 0.125. So as a fraction and then as a multiplier. 6.25%. A loss though, okay? So let's go 100 minus 6.25, 93.75. So how about we just call it 9,375? Since we moved that decimal place 2 spots to the right, we're going to have to take this 100 and move the decimal place 2 spots to the right. So I guess it would probably make sense to simplify it, but whatever. I think we'll just leave it like this. That's the way the book's leaving its answer. Main thing is that we're getting whether to add or subtract from 100 based on whether it's an increase or a decrease or a gain or a loss. So that would be 1 minus 0.0625. X% increase. So we start with 100 and we add X. So I guess this is really all we can do with it. And then if we're going to write that as a multiplier, we're going to do 1 plus point. Well, this is the way the book writes it, and I guess it makes sense because, you know, to turn a percent like into a decimal, you divide by 100%. So 8% divided by 100% is 0.08. X percent divided by 100% would be X over 100. So there's our two values there. And this last one is going to be just the opposite. 100 minus this Y percent divided by 100, which is equal to 1 minus Y over 100. Kind of goofy, but there we go. All right, use the distributive property to write each expression in equivalent form. For example, 500 times this would be 500 plus 500 times that. All right, no calculator necessary here. Actually, this one we're actually going to go backwards, so we're going to kind of factor this. 75 times what? 75 times 1 and 75 times 0.02. This one would be 1,000 times a couple things. It was multiplied by 1. 1,000 times 1 is 1,000. And then negative 0.18. So 1,000 times this is 1,000. 1,000 times this is this product. So I see P as a factor in both of these. P times 1 would be P, and P times R would be PR. All right, this one we're going to actually do the distributive property, 75 times 1, and then, you know, I think we're just supposed to write it like this. Let me check the answer in the book and see what they're looking for, which is obviously what A was up there. Yeah, that's what we're looking for. All right, how about 80 times 1 is 80. And then we'll just do minus 80 times whatever this is. Well, actually, I think we'll just leave it. They're not asking us to simplify it. Just write it as an equivalent expression. One more. A times 1 is A. A times negative R is negative AR. Done. You may remember from Chapter 0, probably not because we didn't do Chapter 0, that the geometric pattern shown in the beginning of a fractal called the Sierpinski triangle. Write a recursive rule that generates the sequence of the shaded areas. Then use your rule to find the area in stage 5. So our recursive rule. Well, I guess we're starting with 32, I guess. Even though that's stage 0, it's term 1. That's a little confusing. So let's go 32, enter. And then what's happening to get from 32 to 24? There's some kind of constant multiplier. Let's see. 24 divided by 32 is 0.75 or 3/4. So 32 times 3/4 gives us 24, which gives us 18. We'll come back to that in a second. But now we have our previous answer times 3/4. And we're going to hit enter repeatedly until we get the value we want. So what's our 5th term? So what we're looking for, or stage 5. Stage 5 has an area of blank. Let's see. We got stage 3 is at 18, or stage 2 is 18. There's stage 3. There's stage 4. There's stage 5. So 7.59375 square units. All right, that's all I got for you. We'll do some reason and apply tomorrow. Hopefully all that makes sense. If not, feel free to shoot me a message in the chat. Have a good one. Adios.